My name is Anthony Osorio. I'm the Senior Design Team Leader. Our project is the LED powered solar panel. And today I will be discussing into further detail these topics: globalization, standard consideration, feasibility and risk analysis, plan of action, multidisciplinary aspects, personnel, budget, end product and other deliverables, and conclusion. The issue that lies mostly with solar panels is the inability to power energy at night. However, our project, the Nightcast, will be able to fill that void in the solar energy industry through the usage of LEDs, because it will be able to provide full efficiency at night, dawn, or dusk. And in order to ensure our product success, we have to make sure that we are following technical guidelines, as well as listening to other cultural feedback. And also, to ensure global market success, we have to set standards by, at least according to the World Trade Organization, the International Organization of Standardization, and IEEE. And as far as cultural feedback, we had an international contact. Her name was Anael. She is a second year undergraduate student. She was French. She mentioned that solar energy is prevalent in her country, and if it was ecological as well as economical, she would definitely see it being feasible in her community. And it also would be very beneficial for homeowners as well as business owners. And the standards that we picked for our project was the ISO 9001. And this one we picked because it ensures, it's actually the staple of quality management that we have for our project. It's actually set for management to have the necessary tools for not only customers, for satisfying customers' needs, but as well as for stakeholders' needs, ensuring them with the highest quality product. And the second standard we picked for our project was the ISO 14001, and this was an internationally agreed standard that sets to reduce waste and acquire stakeholders' trust, as well as competitive and financial advantage. And the feasibility analysis, this is a very critical section for the project development because it allows us to be able to identify how feasible an idea is. And it's actually broken down into 7 categories: technical, resource, economic, schedule, cultural, legal, and marketing. And it's actually ranked, 1 being of equal value, 3 being significantly better than the other one, significantly more important, and then 5 being the greatest importance for the ranking. And also, after analysis and point distribution, it turns out that resource feasibility was the leading one, followed by schedule, and then technical. And then last but not least, we have the feasibility assessment, and this was done with the weight. This was from our previous table that we acquired, and we have to multiply the weight and the score in order to get the weighted score. Then once we get the total sum of the weighted score, you have to divide by the weight, which in this case we wind up getting 4.04. And if we have more than 3, that means that our project is feasible, meaning that the Nightcast is a feasible task and is able to be done. And it is a statistical estimate of our project success rate.
Risk analysis is a way for us as a team to see any problems we will encounter during our project and see them by having them as categories. The 5 categories that we would see for our project is technical, resource, economic, schedule, and legal. These categories will be set in our grouping of which is more risky than the other, shown in the next slide. This table shows that we would plot the number of problems that each category we choose in a grouping of catastrophic, severe, moderate, and to low risk, and show how each of these issues would be either very likely, possible, and unlikely to happen. From our table, we can deduce that resource, technical, and schedule would each have at least one problem from them to be very severe. Moving on. For our plan of action, the plan of action will allow us to make a schedule of tasks that we would need to do for our project and finish it in a proper amount of time. This consists of a statement of work breakdown structure, short for WBS, a grant chart, and a problem evaluation technique chart, and short for PERT chart. Moving on. Our work statement would show the scope of work, which talks about the nightcast being a solar panel that would be powered by a specific LED. The location of work, which is in the FIU Engineering Center in room 3840. The period of performance / deliverable schedule, which is the 3 main dates that we would have to worry about, which is April 19th for our project demonstration, April 21st, which is when the final project proposal is due, and July 29th, when we have to present our final prototype. Then our statement of work would show each team member's responsibility in the next slide, such as Anthony Osorio being the team leader and hardware designer, me, Alejandro Alvarez, being the lead programmer, and Etaine Castaneda Miranda being the lead hardware designer and programmer for the project. Now, here is our work breakdown structure, or WBS, which organizes the tasks that we would need to complete for the success of the project. These would go into phases for our project that would have certain sub-phases to them. Now this is the first part of the Gantt chart, which is a table that would show when we start the certain phases of the project and when the phases would end with the group members that would be involved for that phase. Then moving on, this would be the timeline for each phase that is organized by weeks for the whole duration of our project. Now moving on, this is our PERT chart and has data from the WBS chart and Gantt chart combined to make a sequence of when each phase of our project should be completed. Now we move on to the multidisciplinary aspects, which it would go into the idea that we would only be able to have an optimized and working project by having more than one quality for each of us as a team. By this, there would never be an engineering project done by just having one quality from each of the members of a team. Now I will let my team member Etaine talk about the personnel of our project.
Hello everyone, I'll be finishing off with the rest of the presentation. So to start off, we'll be going over the personnel. Personnel is basically talking about each of our team members that make up this project. In total, we are 3 engineers, 2 electrical engineers, and 1 computer engineer. We will be combining all of our knowledge and our different expertise to really bring this project into fruition. So to start off, we'll be talking about Anthony Osorio. Anthony is an electrical engineer with concentration in power systems and communication systems. He will be our team leader, and as such, he will keep the team organized and make sure that each member is responsible for upholding our project goals. In addition, he will also be hardware designer in this group. He will be assisting with making the prototype and seeing if any more components are needed. Next team member is myself, Etaine Castaneda Miranda. I'm an electrical engineer with concentration in communication systems and autonomous systems, controls, and robotics. I will be lead hardware designer and programming. I'll be overseeing the awning design with the implementation of the LEDs. In addition, I will also be assisting with any program that needs to be added or with any errors that occur. Last but not least, we have Alejandro Alvarez. Alejandro is a computer engineer and has concentrations in programming, circuit analysis, and embedded systems. He will be our lead programmer and provide intelligence to the overall design. In addition, Alejandro will also be providing assistance to the overall design of the project whenever needed. The next topic that I'll be going over is the overall budget for this project. I would like to point out first that in this project, our mentor will also be acting as our sponsor, and as such, this project will be self-funded with the assistance of Dr. Hodges. Therefore, it is even more imperative on our part that we have a laid out budget so that we are organized and responsible, so that we do not waste any time, money, and materials when not needed. The following slide will contain a cost breakdown of what components will be making up our product and their respective costs. We didn't include any lab fees in our table as Dr. Hodges has generously provided us her lab so that we can conduct our research and continue making the design for the project. So as you can see here, I've laid out all the different components that make up the project. We have the Arduino Uno Rev 3, our different sensors, which is a rain sensor, and the photoresistors to detect light, our LED light strips, the 24-volt lithium rechargeable battery pack, the solar panel, and our servo motors, which all come out to the cost of $600. Even before starting the beginning phases of a project, it's crucial and expected to have a detailed understanding of what the end product will consist of and its functions. This section will go into detail of how the NICAS will operate once it has taken its physical form and what it has to offer to its consumers. To start off, we'll be dividing our product into 3 different levels, levels 0, 1, and 2, where the next level will go into further detail than the last. So to start off, we have level 0. Level 0 is a general description of the NICAS. This diagram gives a general overview of what its inputs and outputs are. It's important to note that our product is an attachment that goes above a solar panel. As such, our product will be an input for the solar panel, as can be seen here. The inputs are the servo motors, the sensors, and the power supply. The outputs in this diagram are the 24-volt LEDs, light strips, and the actual extension and the retraction of the awning itself. As you can see here, I've also laid out a table that includes the input and the output in its general description and the overall functionality of the project. Level 1 goes into closer detail of the inputs and outputs that was provided earlier. This diagram specifically highlights of how our components within work and interact with each other. I say within in quotations as there's technically nothing within our product, but the microcontroller along with the sensors will be attached outside of the main frame of the product so that it will not interfere between the interaction between the solar panel and the LED light strips. The sensory array and analog digital converter module represents the combination of sensors that the NICAS will be using. It has 2 inputs, the sensor probes and that will be gathering the data, and the Arduino Uno Rev 3, which will be acting as a power source via the GPIO pin headers. The Arduino Uno Rev 3 is the microcontroller of the product. It will be giving out commands based on the information it receives from the sensors. The inputs for the microcontroller include the rechargeable battery and the converted digital information from the sensory array. The outputs for the microcomputer are the servo motors that will begin extending and extracting the awning and the LED light strips that will activate upon the extension of the awning. Further details of the inputs, outputs, and the functionality of this level 1 diagram can be seen here. Diving further into our product, we have the level 2 diagrams. Our level 2 diagrams are broken down based off the components that were present in the previous level 1 diagram. The box diagram of the rechargeable battery is displayed here. There are only 2 modules within the battery module, the battery itself and the power dividers. The battery module is the actual power bank, which in this instance is the PB240B2 lithium battery. The power divider are voltage dividers for the LED light strips and the Arduino Uno Rev 3. Next, we have our sensory array module. Inside this module are 2 sensors that we plan on incorporating into our product to feed into the microcontroller. Each sensor will use a different pin for the Arduino Uno Rev 3, and there are only 2 sensors that we plan on implementing for now. These are the photoresistors that will detect sunlight or the lack of sunlight, and a rain sensor that will detect rain. Next, we have the box diagram that shows the main components that we'll be using within the microcontroller. Inside this module are 3 sub-modules: the 5-volt DC power connector that connects from the battery to the power of the microcontroller, the GPIO pin headers that has its inputs from the sensory array which will then turn its digital data into the processor, the servo motors, and the LED light strips. The following is a further description of what I previously described. So as overview, in this presentation, we've gone over the globalization, standards consideration, feasibility analysis, risk analysis, plan of action, multidisciplinary aspects, personnel, budget, and end product description, other deliverables. Thank you so much for your time.